out the problem from chapter 3 concept that we talked about. Importantly, we talked about the concept of moment. Now, moment is the product of distance times the perpendicular force. There are two types of moment. One is the bending moment, and other one is the twisting moment. Bending moment is called as bending moment. Twisting moment is called as the torque. Twisting moment is about a radius. So you apply torque on a shaft and you apply bending moment on a beam. So you have in plane twisting, that is torquing a shaft, and you have bending that actually bends the beam. In the last class, I talked to you about this very important concept, how to calculate moment. And I'm going to do a quick recap because this is very important. And let's start with a very simple case that you have this coordinate system. You have this coordinate system. And we are dealing with a three-dimensional coordinate system. We are dealing with a three-dimensional coordinate system, which is X, Y, Z. Unit vector in X direction is I, which means if you travel 1 unit in I direction, that's going to be 1I. If you travel 2 units in I direction, that's going to be 2I. Similarly, you have the unit vector in Y as J and unit vector in Z as K. Now, what I want to show you here is imagine that you have this distance. You have this distance, and this is represented as a vector. This distance is represented as a vector. Now, if you have a force which is going in this direction, the unit of force is 5 Newton. This distance is 2 meters. Now, it is extremely important to understand that the distance is expressed in meters and the force is expressed in Newton. If you look at this particular configuration, do you agree with me that the force going up when it is acting at the distance of 2 meters is going to give me a moment about Z? It's going to give me a moment about Z, moment, which is 2 times 5, which is 10 Newton meter. And since, as you can see, that this moment, when you curl your fingers in the direction of the moment, thumb is pointing in the positive Z direction. So this moment is positive. So I can also write this moment as 10K. Now, why I say that's 10K? Because K is the unit vector in the Z direction. So it goes without saying that this 10K of moment, this is the moment. Moment is always about axis. So about Z axis. And this moment is positive. Do you agree with me? Now I want you to tell me if, very important, if the force is going in the X direction, if the force is going in the X direction, what would be the moment? Moment will be 0 because the force going in X direction is not perpendicular to the distance. You agree with me? Now I want you to observe this important, very important observation. And I want you to remember this. The radius is about x. Can you see the radius is in the x direction? Force is in the y direction. But the moment is about z direction. You agree with me? This is a very important observation. The force is in y direction, but the distance is in x direction, but the resultant of these two, the moment, is in the z direction. And this is the classic definition of cross product. When you have a vector cross with another vector, the resultant is about the third axis. So I want you to remember this. If you have a vector, I'm going to call this vector A. If you have a vector, A, and if that vector is crossed with a vector B, so say if you have this vector A, and if you cross with this vector B, the resultant vector A cross B, which is C, will be along z axis. So this vector will be in K, because if this is I multiplied by J, this will be K. Now why it is like this? Remember circle of vectors. So you have I, you have J, and you have K. So you have I, you have J, and you have K. So I cross J is going to give you K. You agree with me? I cross J is going to give me K. Now what I want to do is, I want to rewrite the same expression using a vector notation. I want to rewrite the same expression using the vector notation. So my radius vector, which is A, my radius vector, do you agree with me? It is 2I. Why it is 2I? Because you are going towards the positive x-axis, so 2I. My force vector is going towards J, and that is going to be 5J. You agree with me? So my moment is equal to R cross F. So R is 2I cross with 5J. This is going to be 10 in the parentheses, I cross J, and what do I get when I do I cross J? Positive K. You agree with me? Now I want to take one more example. Imagine same setup. I, J, and K. Imagine same setup. Your radius again is 2I, but the force, instead of going it up, it's going down. So 5 is the unit of force, and 2 is the unit of distance. And always remember, now I want to show you because there is a difference here. Now you agree with me that the vectorial representation that I have drawn shows that these arrows coincide at same point. Okay, these arrows coincide at same point. However, I want you to think about it. If I were to just calculate the moment, radius times the force is 5 times 10, and can you see that moment will be negative because my thumb would be going inside the board. Do you agree with me? It will be Again, 2 times 5 Newton meter, but this moment is going to be something like this. And when the moment is in the direction shown, curl your fingers in the direction of movement. Your thumb is going inside the board, which is opposite. So this moment is nothing but minus k, or basically z-axis negative. Do you agree with me? Now, one thing you want to remember is whenever you have a force structure like this, you are welcome to extend the vector in the positive and negative direction. What does it mean? It means in theory, this vector could be anywhere on this line. And it's easier for us to visualize this if I were to show this vector something like this. So it is absolutely possible to move the vector along the line of action. So you can actually take this force and move it around the line of action so that the end of the first vector, it always has to be radius, because you are taking the radius cross with s. So the end of the first vector is the beginning of the second vector. Everyone understood this? So you can extend the vector in the line of action of force. Now, I would do the exact same thing. You agree with me? In this case, my R is going to be 2I. But my F is going to be negative 5J. Do you agree with me? Now, I'm going to do moment, which is R cross F. R is 2I multiplied by minus 5J, and this answer is going to be minus 10, but the product is going to be I cross J, and I cross J is still K. You agree with me? Which means the answer that we got from a simple moment, we got the same answer performing the vector calculation. Everyone understood this? Now, one interesting case is in this particular problem, my radius was aligned with x, my force was aligned with y, but it doesn't have to be. As long as both the vectors are represented in a consistent coordinate frame, it should work. Yeah. We got 10 minus because the momentum is actually on the opposite side, right? Yeah, so basically, okay, let me put it this way. Look at this picture. Radius times force. I'm noticing something that is inconsistent. Should not be J into I because it's no. No. Always R is 2I. F is minus 5J. You cannot change the order of cross product. Your answers are going to be wrong. That's why I wanted to take this example to make it absolutely clear that you have this radius, which is in the same direction as the previous radius. So Ji, the 2I, the radius is positive, but the force, the direction has changed. And now I cross J, look at the circles. The cross product is still K, but since your force is going in the downward direction, that this negative sign popped up, which correlates with what we observe in the physical setup. Everyone understood this? This is extremely important. Now, in the last few lessons, we talked about the vector representation. You could potentially have force represented in a different vector notation and the radius that is represented in a different vector notation. But to perform the cross product, both these vectors must be in the same coordinate system or same vector notation. And I will take an example and explain it to you in just a minute. But before I go any further, everyone understood that this is how we can solve the problem. You can solve the problem by looking at the setup, or you can solve the problem writing the vectors. If you have a two-dimensional figure or two-dimensional case of forces, solving it is very simple because you can actually visualize whether it is clockwise or whether it is counterclockwise. Imagine if your radius is in 3 dimensions and your force is in 3 dimensions, it's very difficult to visualize what force is multiplying with what radius. So the technique that I have shown here is simple multiplication, works very well for the two-dimensional cases, but it does not work, or it may not give you correct answers for three-dimensional case. This is extremely important for manufacturing students and robotic students, because when we go to the next class, most likely I would be teaching, which is RAS 230, kinematics. All these concepts will be crucial. We need to have absolute command and mastery over the vector. Otherwise, you cannot do kinematics. So now let me take one more problem. Now let's see that this is the coordinate system. This is the coordinate system, and I will leave that problem as is. So this is 2i, or this is 2 units. 2 units. This is my x, this is my y, and then maybe I have z. This is 2 units, and now I have a force which is 10 newtons. I have a force 10 newtons, which is at an angle 30 degrees. I have this force which is 10 newtons, which is at an angle 30 degrees. And now I want to ask you this question: what is the total moment given by this force? What is the total moment given by the force? Do you agree with me that your radius, right now the way we have shown, that radius, which is 2 meters, is not perpendicular to the force? Do you agree with me? So there are 2 ways that you can do this. Either you can make the force perpendicular to the radius. What that means is you can actually find out the component of forces, component of force. You can find component of force. Since this is 30 degrees, you agree with me that this f of y is going to be 10 sine 30. F of x is going to be 10 cosine 30. And in case if you need a little refresher, this is 10, this is 30. So this is 10 cosine 30, and this is 10 sine 30. You agree with me? Now, do you agree with me, even though the resultant force, which is F, this force F, is not perpendicular to the radius, but you have resolved the components of the force you have resolved the component of the force along the radius and perpendicular to the radius. Do you agree with me? So can you agree with me that the force, which is 10 cosine 30, the force 10 cosine 30 is the same direction as the radius. So it's not going to give us any moment. You agree with me? The horizontal force is not going to give us moment, but the vertical force 10 sine 30 is going to give me a moment. So you agree with me? The moment, which would be 2, which is radius, multiplied by 10 sine 30. Do you agree with me? So this is 10 Newton meter. The horizontal component is not going to give me any moment. Now, there is another way of looking at this problem. Instead of resolving the force, what if I resolve the distance? So what I do is, what if I resolve the distance? So for an example, I take it down, and this is 2. This is 2. So I find out the component of 2. So basically, I find I actually resolve this component of 2. So let me resolve this properly in this direction. So this distance is 2. This distance, this angle is 90 degrees. Since this is 30 degrees, this angle is going to be 30 degrees. Since this angle is 90 degrees, you agree with me, this angle is going to be 60 degrees. You agree with me? So what I did, I extended the line of action of force, and then I drew the parallel and perpendicular lines on the line of action of force, and I have found out the component of the distance. Do you agree with me? This distance is going to be 2 sine 30, and this distance is going to be 2 cosine 30. Now I will draw this figure. So this is the radius. This is the force. What I did, I draw the line perpendicular. This is the radius to this angle is 30 degrees. This is 90 degrees. So this becomes 30 degrees. Since this is 90 degrees, this becomes 60 degrees. Do you agree with me? So instead of resolving the force in its x and y component, I resolve the distances or the radius along perpendicular to the force and parallel to the force. Do you agree with me? And now this radius, this guy, this is 2 sine 30, or you can see that this is 2 cosine 60. Are you with me? And the force, which is like this, is 10. Now moment is 2 sine 30 multiplied by 10, which is same as 10 Newton meter. My question to you is, in what direction this movement is going to be? Whether it would be, you agree, it would be about z. Whether this movement is going to be positive or whether this movement is going to be negative. Can you see the force Fy is going up? Curl your fingers in the direction of the movement. Force times the radius. Curl your fingers in the direction of movement. Thumb is pointing in the positive z-axis, so the moment will be positive. So you can just say something like this, positive sign. It's always good to show the direction. Now, if I were to do using vector representation, how would it look like? Can someone tell me if I want to represent force? If I want to represent force in maybe some I and some J, what should I write? Vertical component of force is aligned with J component. Horizontal component of force is aligned with I component. So unit vector. So can I say this is 10 cosine 30 plus 10 sine 30. You agree with me? So 10 cosine 30 is the horizontal component of force in the positive I direction, and 10 sine 30 is the vertical component of force in the positive J direction. Everyone understood this? And now if I want to find the moment, I would, and what is R? R is gonna be 2I. Do you agree with me? Extremely important observation. Extremely important observation is I, J, and K. It's the same consistent coordinate system, same unit vectors that are representing both vectors, force and the radius. Do you agree with me? The same unit vectors, I, J's, and K's, they are representing the force and the radius. Now, if you take the product, I'm going to write this down. Moment by definition is R cross F. Moment by definition is R cross F, and R is 2I cross F is 10 cosine 30I plus 10 sine 30J. Now, before I go any further, everyone understood why this is 10 cosine 30I? Because when you take the x component of the force, it is the same direction as positive I. When you take the y component of the force, it is in the same direction as positive J. That's why you have 10 cosine 30I and 10 sine 30J. Everyone understood this? Now what I need to do is just multiply. So 2 times 10 cosine 30 I cross I plus 10 sine 30 I cross J. Do you agree with me? And this is just a product. Okay, this is not a cross product. This is just multiplying two numbers. So what is I cross I? 0. I cross J? So you have 2 times. So I forgot 2 times. So can you see this is 10. So, oh, I made a mistake here. I want you to note. Can somebody notice? Can somebody quickly tell me what mistake I made? Yeah. No. I made a mistake. So, yeah, tell me what mistake I made. Yeah, I forgot to multiply 2 on the same side. So 2 times 10 sine 30 is 5. 5 times 2 is 10. 10K. That was a mistake. Probably you said the same thing, right? Okay. See, I couldn't hear you. Everyone understood this? Now let me ask you a tricky question. If I were to do the same jugglery by resolving, if I were to do the same jugglery by resolving the radius, what should I do? Can you see the first part? We resolve the force. The second part, we resolve the radius. I did M is equal to R cross F. When I resolve the force, if I were to resolve the radius, what do I need to do? You agree with me? If I want to resolve the radius, I cannot use I's and J's. I need to construct another coordinate system which is perpendicular to the force and parallel to the force and find out the radius. You can do that, but we will work on that. So, coordinate systems, you can choose the coordinate systems that make your solution easy. So, again, you can play a lot of tricks, but now we will work out some problems. Now, first and foremost, I want you to look at this beam. You agree with me that this beam is fixed at one end and free at the other end. You agree with me? Beam is fixed at one end and free at another end. This is called as the cantilever beam. This is called as the cantilever beam. Now, why is it called as the cantilever beam? Cantilever beam means you have all the forces acting on the beam, and one side of beam is held fixed. Now, I want you to imagine other scenarios. Instead of beam being fixed, if this beam would have been hinged, what would happen? If this beam, instead of being fixed, if it was hinged, what would happen? It would roll. In other words, cantilever beam can cancel out the moments on the beam. Cantilever beam can cancel out the moment on the beam, but a hinge beam cannot cancel out the moment. You agree with me? Now, how do I represent that in engineering terms? What this means is cantilever beam can provide support in x direction. So this is f of x. This can send the support in y direction, f of y, and it can support the moment, which is m of z. Yeah. Look at the beam. Does it look big to you? Exactly. Hinge means we have beams which are hinged. Everyone understood this? So when you have a cantilever support can give you reaction forces, and cantilever support can also give you reaction moments. Now I want to ask you this question. If I don't have a cantilever beam, and if I have a hinged beam, what would happen? If I have a hinged beam, you agree with me, and I want you to notice this very, very carefully. If you have a cantilever beam, this cantilever beam is not going forward in x direction. This cantilever beam is not going vertical in y direction. And this cantilever beam is also not rotating. You agree with me? Which means all the forces and all the moments on this cantilever beam are balanced. Everyone understood this? However, if you have a hinged beam, then what's going to happen is hinged beam is going to roll. It's going to rotate. It means the moment at the hinge, the moment at the hinge, it cannot support any moment at the hinge, but it can support the forces in x direction and y direction. So if you had a hinged beam, then you can actually, the reaction would be the forces in the x direction and forces in the y direction. Do you agree with me? Now, what this problem is asking us, and I want to explain this problem a little bit in more depth. It is just asking, find the moment of the forces. But I want to extend this problem, because that's an entire chapter. So let's discuss that entire chapter in one problem. I want to find out the reaction forces and reaction moment. Can someone tell me what is the God equation of statics? What is the God equation for statics? Static equilibrium. It means if you want this beam to be in equilibrium, summation of forces in x, y, and z direction is 0. Summation of moments about x, about y, and about z are 0. Now let me set up the coordinate system. Extremely important. This is your x. This is your y. Do you agree with me? I can solve this problem vectorially, but typically, you agree with me that this is a two-dimensional problem. It means this is a planar beam. You don't have any forces in z direction. You only have moment in the z direction. So it's just easier to solve this problem by just looking at it. But before you start this problem, first and foremost, you notice you have one force F1 that is perpendicular, but you have force F2 which is at an angle, and you have another force which is again at an angle. Do you agree with me? So first and foremost, I'm going to resolve these forces. So do you agree with me? This force is going to be F3 cosine 30. There is going to be a horizontal component. This is going to be F3 sine 30. You agree with me? This guy, can someone tell me what would this be? So if you tell me what this angle is, F2 cosine theta. And then this guy is going to be F2 sine theta. And in case if you are wondering what is this theta, this is the classic triangle 5, 4, 3. Since this angle is theta, you agree with me, this angle is theta. So this theta is tan inverse 3/4. Everyone agree? Any questions about resolving the forces? Everyone understood how the forces are resolved? Now I'm going to apply the conditions of equilibrium. So summation of forces in the x direction is equal to 0. Let's start from the left. Oh, I made a mistake. I'm going to call this fx, call this fy. So this is fx, fy. So fx Can you see that Fx is aligned with positive I direction? So this Fx is positive. Positive Fx. You agree with me? Fx. Now you have F2 sine theta. F2 sine theta. Can you see that is in the negative x direction? So it's going to be minus F2 sine theta. Can someone tell me what is theta? What is tan inverse of 3 by 4? 36 degrees? 36. And then can you see I have F3 sine 30. F of x is positive because it is in the positive I direction. F2 sine 36 is negative because it is going down, and F3 sine 30 is in the positive direction. You agree with me? So once I solve this, I can substitute value of f of x. I can get the value of f of x because summation is going to be 0 minus f2 is 500 sine 36 plus f3 is 160 sine 30. Can you tell me what is the value of f of x? Do you agree with me? Now let's do summation of f of y is equal to 0. And why summation of f of y is equal to 0? Because these are the God equations. F of y is equal to 0. You have plus f of y. Can you see f1, which is going down? So which will be minus 375. Then you are going to have f2 cosine 36. And then you are going to have minus minus f3 cosine 30. So fy minus 375 minus f2 is 500 cosine 36 minus f3 is 160 cosine 30. Can you see the only unknown in this equation is fy. So you can solve what is the value of fx, what is the value of fy. Cosine 30. Do you agree with me? Now let's go to the question that has been asked. What is the reaction moment, or what is the moment at point A? Again, same logic. Summation of moments. This is the God equation. Summation of moment about z is equal to 0. You agree with me? Summation of moment about z is equal to 0. First and foremost question. This moment mz, you don't know its value. Is it positive or negative? Curl your fingers in the direction of moment. Thumb is pointing towards positive z axis. So this reaction moment is positive. So this reaction moment is plus mg. Now look at the moment that is given by the force F1. Force F1 is going down. Curl your fingers in the direction of the movement given by force F1. Is it positive or negative? Negative. So this is going to be minus 8 times 375. Why 8? Because 8 is the distance. Perpendicular force is 375. Now comes the tricky part. Now comes the tricky part. I want you to look at very carefully. This needs, I need to magnify this a little bit. I need to look at very carefully. When F2 is applied, can you see that I resolve F2 in the horizontal direction and I resolve F2 in the vertical direction? Do you agree with me? It is asking me the moment at A. It is asking me the moment at A. So do you agree with me that F2 sine theta is passing through A? F2 sine theta is passing through A. So it will not give me any moment. However, F2 cosine theta is at distance 6 plus 8, which is 14. So this distance 14 will give me moment. Do you agree with me? This is a very important observation. If you look at this figure very carefully, what they are doing, they are asking to find the moment at point A. To find the moment, the force needs to be away from the line of action of the hinge or the point of action of moment. Since F2 sine theta is passing through A, it's not going to give you any moment. However, F2 cosine theta is going vertically down, it will give you moment. Everyone understood this? Now, whether this moment will be positive or negative, curl your fingers in the direction of movement. F2 cosine theta multiplied by 14. So curl your fingers, thumb is going in, so the moment is negative. Now I want to extend the same logic to F3. F3 also has two components. One component which is going vertically down and another component which is going horizontally. However, the difference here is that vertical component is at distance 19 units or 19 feet. 14 plus 5, 19 units, 19 feet. And the horizontal component is at distance 0.5. You agree with me? It means in this particular case, horizontal component and vertical component of force F3, horizontal component and vertical component of force F3 is given a moment. I want you to think about it for a second. We are trying to find out the moment about this point. I'm trying to find out the moment about this point. Do you see that point A is in the same line as F2 sine theta? So F2 sine theta, the Greek force, horizontal force, is not going to give you any moment. However, that point A is offsetted by 0.5 feet in the vertical direction and 19 feet in the horizontal direction. So both the components of F3 will give you moment. Do you agree with me? Everyone understood this? So I will write that thing down. So if you look at here, mz, then you are going to have F2 cosine 36 multiplied by 14, then plus F2 sine 36 multiplied by 0. I just want to write this down. Then you are going to have minus f3 cosine 30 times 19. And then I will have curl your fingers plus f3 sine 30 multiplied by 0.5. Everyone agrees? Any question? 2.5. And now what your job is to plug in the value of f2. F2 is 160. Plug in the value of f2. F3 is 500. And find the value of mz. Can you see there is only one unknown? It is entire equations. So you should be able to solve the problem. F2. Oh, okay. F2 is 500. Yeah, we are right. F2 is 500. And F3 is 160. Yeah.
You could explain the first part, like how did we know that it's positive?
mz. Okay. Now, please try to understand. A priori, mz is the reaction moment. It means mz is counteracting all the forces that are making that beam unstable. I just assumed it. Okay, I just assumed it. Now, if I perform this calculation and I found out the mz comes up with a negative sign, it means the direction that I have assumed is incorrect. If at the end, when I carry out this calculation, if my mz turns out to be positive, yeah, then my direction that I have assumed is correct. So please try to understand in this problem, the reaction forces f of x, f of y, and the reaction moment f of z, I assume, okay, nobody has prevented you from assuming those forces in the opposite direction. The only change would be that please note, if you assume your f of x going towards the left hand side, there should be a negative sign here. You agree with me? If you assume your f of y going down, then it can't be positive. There has to be a negative sign here. If you assume mz going in the clockwise direction, the mz here is negative. Everyone understood this? Okay. Now the next problem. Oops. So the next problem I will work out. Okay, finish. So is this problem? Let me. Okay. I'm going to treat that problem exactly same as the previous problem. We have to find out the moment of each force about point A. So what I want to do is, I first want to find out the vertical force reaction, which is f of x, f of y. For y, I want to draw PowerPoint is acting up. Then I have the horizontal force, which is f of x, f of y, and then I'm going to assume the moment is m of z. Now, starting summation of forces in x direction is equal to 0. So what you have is the first force f of x is positive. Then you have this 250 newtons. Can someone tell me what is the horizontal component of this 250 newtons? What is the horizontal component of this 250 newtons? Would it be positive or negative? Positive. 250 sine 30. Now let's go to the next. What about F2? What would be the horizontal component of F2? This is 60 degrees. Can you see it would be minus 300 cosine 30? Oh, cosine 60. Now what would be, can someone tell me, it's easier to just tell me the angle. This angle is going to be 36 degrees. So, and this angle is going to be 54 degrees. So, can someone tell me what would be the horizontal component of 500? Positive or negative? Right? Now, summation of forces in y direction is equal to 0. So, I will do the hard part. I wrote the 0. Can you tell me what should I write? What would be the first, what is the first force you see? F of y? Is it positive or negative? Then what is the next force you see? 250 Newton minus 250 cosine 30. Then what next force you see? 300 minus 300 and last but not least minus 500 sine 54, right? We agree with me? Now tell me the same thing about the moments. Summation of moments about z is equal to 0 is 0. So is it positive or negative? The moment mz is positive. You agree with me? Now I want you to observe this very carefully. The horizontal component of force is going to go in this direction. The vertical component of force is going to go in this direction. So do you agree with me? The horizontal component of force is passing to point A. It's not going to give you any moment. Only the vertical component of force is going to give you the moment. What is the vertical component of force? 250 cosine 30. What is the distance between point A and the point of action of force? 2 meters. So, and the moment given by that vertical force, would it be positive or negative? So it's going to be minus 250 cosine 30 multiplied by 2. Do you agree with me? Let's go further. Now you have this force F2. Let me show you the horizontal and vertical component of this force. The horizontal component is over here. The vertical component is over here. Do you agree with me? The horizontal component of F2 is passing through A. So it's not going to give you any movement. But the vertical component of F2 is at distance 5 meters. So it's going to give you a moment. And that moment, would it be positive or negative? Negative. So minus 300 sine 60 multiplied by 5. Now the last but not least. Yeah. So in this problem, okay, show me, just tell me, what would be so can you see that the horizontal component of this force F3 is going to give you a moment. Vertical component of force F3 is going to give you a moment. And I want you to look at this part a little bit more carefully. So check this out. You have this horizontal component. And then you have this vertical component. Horizontal component is F3 cosine 54. And vertical component is F3 sine 54. Do you agree with me? The horizontal component of F3 is at the lever arm on the radius at the lever arm. What is the lever arm of the horizontal component? Horizontal component, what is the distance? Horizontal component. Can you see this horizontal component? The perpendicular distance is 4. So F3 cosine 54 multiplied by 4 is going to give you the moment. Whether that moment be positive or negative, curl your fingers in the direction of moment, and that moment is going to be positive. So this moment is going to be positive. F3, which is 500 cosine 54 times 4. Now let's, yeah.
How do we? How do we get it?
How did we get what?
Positive.
Moment from X3? So can you see that this force, horizontal force, is going to give a moment in this direction, right? Would you agree that this is going to give a moment like this? And this vertical force is going to give a moment in this direction. I want you to focus at A. Horizontal force about A is going to give you the moment which is positive. Vertical force about A is going to give you a moment that is negative. And what would be the distance of the vertical moment? 5. Do you agree with me? This sets up the problem. So now you should be able to find out the value of f of x. You should be able to find out the value of f of y. And you should be able to find out the value of moment about z. Yeah.
It's not a setting strong rule. It's basically the force you can show in this direction.
Okay. So it depends upon where your movement point is. I'll give you an example. Imagine that you have a force and the force is going in this direction. The distance is this. You agree with me that this force multiplied by this distance is going to give you a moment, something like this, right? Just rotate the force about the hinge point. Now imagine, same case, you have the hinge here and your force is here. Do you agree with me? This is going to rotate in the opposite direction. However, your coordinate system must be consistent. What do I mean by coordinate system should be consistent? So if this is x, this is y, this has to be z. Same thing. This is x, this is y, this is z. You can't change the coordinate system. Always right hand coordinate system. Everyone understood this? So please be very careful with this setup. Okay, let's solve. So this problem I'm gonna give you as a homework. Now here is the difference. They are asking you to find out the moment about point B. Can you locate that? This is not moment about point A, but this is moment about point B. Everyone understood this? Now let's see this problem. In this problem, what you have is you have force B and you have force C. So what you have is you have a beam, and on this beam you have two forces. On this beam you have two forces. So if I were to draw the free body diagram, this is the beam and this is the vertical line. This is the vertical line, and what you have is you have one force which is going like this. You have the other force which is going like this. So you have FB and you have FC. You have FB and you have FC. This angle is 25 degrees. This angle is 30 degrees. And this guy is actually 20 degrees. This guy is 20 degrees. What you have is you have this inclined rod. This rod is inclined, and on this inclined rod, you are applying forces. Everyone understood this? So you agree with me that this case you can see from top. You can see from top. And if you were to look from top, this is what you're gonna see. You're gonna see this beam, wherein you will see this point B. You will see this point C. This distance is going to be 2.5 cosine 20, and this distance is going to be 0.75 cosine 20. Do you agree with me? Because this rod is at an angle. If you look from top, you are going to see the projection of that angle. So that the distance that you are going to see is 250 cosine 20, and you are going to see 250 sine 30. Now, if you look at the forces, you are going to see again two components of forces. This component is going to be FB cosine 25, and you are going to see this component as FC cosine 30. You would also see FB sine 25, and you would also see FC. So I showed the wrong direction. You would see FC sine 30. You agree with me? Now, FB sine 25 and FC sine 30, they go through this point A. If you look at this point A, FB sine 25 and FC sine 30, they go through this point A. So they will not give you any moment. However, if you look at FB cosine 30, so this is FB cosine 25 and FC cosine 30, they will give you a moment. Now, if you want to solve this problem, consider this moment mg, summation of moment about z is equal to 0. So you have positive moment, and you can see FB cosine 25, curl your fingers in the direction of moment. This is gonna give you, I made a mistake, this FZ is negative. Because if you curl your fingers in the direction of moment, FZ is negative. It's going to be FB cosine 25 times 2.5 cosine 20, then plus FC cosine 30 multiplied by the lever arm 2.5 cosine 30 plus 0.75 cosine 20. Solve this and get the value of mg. You agree with me? Any questions? Yeah.
What are the other example that last question, what scenario would the moment?
I just assumed the reaction moment, right? I just assumed in this case, looking at the problem, I saw one force is going up, other force is going up. So the reaction moment, so that everything gets cancelled out to the clockwise. So that's what I'm doing. Okay. Now time for quiz.